When fires occur in populated areas, they can take a terrible toll on people and property. But in wildlands, fires give plant communities a fresh start. They're not one-time events, but recurring forces like wind, rain, and fog. They clear out dominant species and reveal the diversity that lies in wait for the sunny, nutrient-rich conditions that occur only after a fire. They allow scientists to explore new places and make new discoveries. The Morgan Fire was sparked on private land near Perkins Canyon on September 8, 2013. The flames lasted for 5 days and charred 3,100 acres on the south and east sides of the mountain. That's a small fire by recent California standards. Nothing like the 260,000 acres hit by the Rim Fire in the Sierra Nevada that same year. But the Morgan Fire was plenty scary at the time. Flames shot up 80 to 100 feet. From a few miles away in Pleasant Hill, the mountain looked like a volcano. It took 6 planes, 7 helicopters, 25 bulldozers, 142 fire engines, and almost 1,400 people to put it out. And the changes the fire wrought were dramatic. Right afterward, the grass in the meadow near the entrance to Perkins Canyon was black. The leaves on some of the big old oaks were toasted. In some places, the fire burned right down to the oak's roots, leaving a big hole where the roots used to be. Once dense chaparral areas were a graveyard of shrub skeletons. The whole landscape had a sad, dystopian feel. Yet, as soon as the flames died down, there were signs of life. Rodents were turning over the blackened soil. A week later, some grasses poked up in the meadow, and within a month, soap plant, a vetch, and a native mustard popped up. In 6 weeks, shrubs like chamise and yerba santa were re-sprouting. The mood changed from sadness to excitement. As botanist Heath Bartosh said in a Bay Nature article, "Nature's pulling back the curtain. Let the play begin. We'll see who shows up and gives the best performance." State Park scientist Cyndy Shafer was on the ground during the Morgan Fire, which was allowed to burn in certain areas inside the park. Outside those areas, firefighters intervened to protect people and property. The strategy worked so well that Morgan came to be called the perfect fire.
It was the perfect fire because there was no damage to human communities that was of any significance, no loss of homes or lives. It was also the perfect fire because a lot of the areas that burned really can benefit from that burn.
Here's a look at what the recovery was like at Perkins Canyon in the first year after the fire. The mountain was black in September, brown in December, green in April, and pure gold in July. Though it was a drought year, native wildflowers flourished, pushing up before they were crowded out by non-native annual grasses. Save Mount Diablo's newly launched Mary Bowerman Science and Research Program made small grants to scientists who were interested in studying the changes. It began hosting a yearly colloquium to share their findings. It also brought scientists together for bioblitzes, recording every species of plant or animal they could find in a 24-hour period. One of the most active post-fire researchers was UC Berkeley's Kip Will, who began a study of Mount Diablo's beetles and other arthropods. Arthropods are animals with external skeletons and no backbone, including ants, spiders, scorpions, moths, and millipedes. I knew from personal experience that at least one arthropod species had benefited from the fire. When Save Mount Diablo's Seth Adams and I were roaming around Perkins Canyon after the flames died down, charcoal beetles bit our hands and necks. We'd never seen them before, but we learned later that firefighters know them well. Infrared sensors under their wings lure them from one fire to another. They eat, mate, and lay eggs under the bark of smoking trees. The summer after the fire, Kip and his students began trapping arthropods at Perkins Canyon every month. They went out at the time of the new moon, when nocturnal arthropods are most active. The first year, they found that beetles were twice as numerous in burned as in unburned areas, an effect that faded over time. They also found 16 species of moths, never before recorded in Contra Costa County, including the elegant sphinx moth with a wingspan of 4 inches, which is now the mountain's largest insect. Five years later, Kip and his students were still at it, learning not so much about the fire as about the intricacies of life on the mountain. Kip fondly recalls finding some rare beetles that hang out underground with ants.
They're blind, soil-dwelling things, they're mammal-associate, things that are pretty rarely collected. These are all part of hidden diversity that's, I think, typical of these dry Mediterranean climate areas. They also probably are quite resistant to fire.
Not every fire is an ecological boon, of course, even in wild areas. If too many fires come too quickly, severe erosion can occur. Weedy annual plants supporting fewer animal species can invade. Here's a map that shows how many times the state park was hit by fires of 1,000 acres or more, from 1891 to the year 2000. Areas in yellow burn once during that time. Areas in gold burn twice. Areas in orange burn 3 times, and areas in red 4 times. That's a lot of fires, but so far, they've been spread out enough in space and time to allow the mountain time to recover. "5 springs after the Morgan fire," Heath said.
Hey, just a few years ago, that was burnt to a crisp. Guess what? 40 years ago, the same thing happened. And then guess what? 40 years before that, the same thing happened. And just the cycle of life about the mountain that's so intriguing, and the resiliency of all those communities. It's fire adapted.
In our next segment, we'll focus on Mount Diablo's trees. Which oaks and pines live here, and why? And how did these and other trees respond to the 2013 fire? At the end of that segment, we'll suggest a hike at Perkins Canyon that will help you answer those questions.